So let us do moment of inertia of some symmetric bodies. Okay. First, a thin rod. Okay. About an axis passing through one end of the rod and perpendicular to it. That means I have a rod like this. The axis is like this. Okay, it's rotating about this axis, this rod. So the length of the rod is L. So let me call it x equals 0 and this is x equals L. Now at a distance x, let me take a small element dx. Okay, so total mass of the rod is capital M, say. Okay, so mass per unit length clearly M by L. So the mass of this element dx is per unit length, it is M by L. So for dx length it is M by L into dx. So mass of this dx length is dm equals M by L into dx. So the perpendicular distance of this element from the axis is x. So the moment of inertia of this element is dm into x square. So it is M by L into dx into x square, right? So what will be the total moment of inertia of the rod? You have to integrate it. So we will get M by L outside as constant, integral x square dx from 0 to L. So you will write I as M by L into, this will be L cube by 3, as it is x cube by 3, upper limit L cube by 3 minus lower limit 0, so it is L cube by 3. So it is coming out to be 1/3 ml square. Okay. Now if they ask you about an axis passing through the center or the center of mass of the rod, okay, and perpendicular to length, okay, about this axis. Now already you know the moment of inertia about this axis. This is I, you already know, and this is supposed to be ICM. Okay, so you will write, you will apply parallel axis theorem. Parallel axis theorem, it will be I is ICM plus MA square. Now what is the perpendicular distance between the parallel axis? It is L by 2, right? Okay, so I is 1/3 ml square. ICM plus M L by 2 square. Okay, so ICM will become 1/3 ml square minus 1/4 ml square. That is ICM will be 1/12 ml square. Okay, fine. Now let us calculate the moment of inertia of a ring, a thin ring. Okay. About an axis passing through its center and perpendicular to its plane. Like this, a ring is there. Okay, so from center the axis passes and it is perpendicular to the plane of the ring. Okay, the radius is r. So consider a small element here, call it dm, this mass. So the perpendicular length is r from the axis, so the di will be mass into perpendicular distance square. So for the entire ring I will be integral di, that is r square is a constant integral dm, so it is the total mass, integral dm is the total mass of the ring. Alright, so it will be mr square. Okay, fine. Now if they ask you what is the moment of inertia about a diametrical axis, okay, about an axis like this, okay, this is a diametrical axis, fine, passing through the center, okay, it's a diameter, okay. So how will you do it? Take another diametrical axis, okay, fine, like this, and like this. Now these two diametrical axes are very much symmetric there, okay, so they will have, by symmetry they will have the same moment of inertia. It is equivalent to rotate the ring about the red axis as well as the yellow axis. Okay, so they have the same moment of inertia. Alright, clear? Call it I. Also, the moment of inertia about this axis will be I. Now, if you consider the perpendicular axis theorem, so you see, these two are perpendicular axes lying in the plane of the ring, and there is a third axis perpendicular to the plane of the ring and passing through the point of intersection, that is the center. Okay, clear? Now this axis which is coming out of the screen like this, okay, this axis, if you put your pen perpendicularly at this point, so this axis is coming out of the plane of the ring, you can call it Iz, the moment of inertia. Now this axis which is coming out of the plane of the ring, this is actually this axis. From this point it is the z axis, right, perpendicular to the plane of the ring. So you will certainly have I plus I about the x and y axis. They have the same value for symmetry. This is equals to Iz. Now Iz you already know mr square. So 2I is mr square. So it will be half mr square. Okay. Now about a tangential axis. Lying in the plane of the lamina of the ring. Okay. So already you have the moment of inertia about this diametrical axis. Now this is passing through the center of mass, so it is ICM, you already know. So it is very easy to calculate the moment of inertia about this tangential axis lying in the plane of the ring. Okay, call it I. So use parallel axis theorem. So the distance between these two parallel axes is r, right? The radius. So I will be ICM plus mr square. Now ICM you already have half mr square plus mr square. So I will become 3 by 2 mr square. Alright, clear? Now let us calculate about a tangential axis. Perpendicular to the plane of the ring. Okay, so we have the ring like this. So already we know the moment of inertia about this axis. Okay, this is ICM because it is passing through the center of mass of the ring. So if I know this one, it's very easy to calculate this one about a tangential axis. Okay, pass perpendicular to the plane. Okay, call it I. So I will be the perpendicular distance is r. So ICM plus mr square. That is, now for this axis we did it mr square, right? So it is mr square plus mr square. So it is 2 mr square. Now let us calculate the moment of inertia of a disk. Okay, suppose we have a disk here. Okay, so first the axis will be like this, passing through the center and perpendicular to the plane of the disk. It is rotating. Okay, the radius of the disk is r. Okay, now we will first consider a strip of radius x, okay, and width dx. Okay, this width is consider a strip of radius x and width dx. Okay, so this much is dx. Now let's say the total mass is capital M of this disk and total area of this disk is pi capital R square. Okay, so mass per unit area will be m by pi r square. So what is the area of the strip? The area of the strip will be the area under this outer circle minus the area of the inner circle. Okay, so I will get the area of the strip. Alright, fine. So it will be pi x plus dx square minus pi x square. So it will be pi if I take pi common, a square minus b square, so it will be this plus this is 2x plus dx, x minus x gone, so it is dx. Okay, so if you multiply 2 pi x dx plus pi dx square, right? Okay, so as dx is very small, so dx square will be even smaller, so the second order smaller can be neglected. So the second order smallness can be neglected, it is ignored. So it is coming out to be 2 pi x dx. Okay, so the mass per unit area is this. So what is the mass of this area? So mass of the strip is dm equals m by pi r square into 2 pi x dx. So it will be pi and pi cancel, so 2m x dx by r square. Okay, now this strip can be considered as a ring, you can visualize. So you know the moment of inertia of this ring about this axis, this is mr square, and the radius of this ring is x. Okay, so di, the moment of inertia of the strip, it is dm into x square. So integral di, I'll get integral dm এর value 2mx dx by r square into x square. So I'll get I, the total moment of inertia of the disk. 2m by r square will be outside as constant, so it is x cube dx. So x, the limit of x is 0 to r, from origin 0 to r. Okay, so it will become 2m by r square. This will be x4 by 4, so it is r4 by 4 minus lower limit 0, I am not writing, so it is 2 and this becomes r square. So it is half mr square. Alright, okay, fine. So now about the diametrical axis. Of this disk, it is easy to find just as ring. Okay, this I. So perpendicular axis theorem, I plus I will be Iz. By symmetry they are equal, so Ix and Iy. So I plus I is Iz, Ix plus Iy is Iz. So 2I is Iz, already I know half mr square. So it will be 1 by 4 mr square. Alright, and for a tangential axis, lying in the plane, for this disk, the diametrical axis, as we have done in case of the ring, is ICM. So by parallel axis theorem we can find about this tangential axis I. The distance is capital R, so it will be I is ICM plus mr square. So 1 by 4 mr square about the diametrical axis plus mr square. So it will become 5 by 4 mr square. And about the tangential axis, perpendicular to the plane, we know this as ICM, so we need to calculate this as I ZAR. So parallel access theorem, as in the previous case. You already knows this ICM. The first case, it is half mr square, this axis, right? So it will be half mr square plus mr square, that is 3 by 2 mr square, right? Alright, fine.